Hi there, and welcome to this lesson. In this lesson, we'll be learning differential calculus, and under differential calculus, we'll be learning to find the derivative of a function of a function. Interesting. So, at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so you see everything clearly. And as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch. Okay, we would be more than happy to help, and you can do so via the course dashboard. Okay, so let's jump right into the lesson. So, differential calculus, the derivative of a function of a function. Now, what exactly is a function of a function? Now, when we think of functions, we somehow think of them as processes. Okay, for example, you have a function y equals, let's say, 2x. You basically have an input x, and when you put that input x into the, let's say x is 2, you put that input x into the function, and the function gives you an output, a value for y. And that's pretty much what functions are. Now, if we consider the function y equals 2x plus 1 all cubed, okay, all to the power of 3. Now, this is, like I said, just like a processor. You put in an input and it gives you an output. Now, there's something very interesting about this function in that it is a function of a function. Now, I have two functions here, and my first function being 2x plus 1. Okay, so let's say I have an input, and I'm going to put my input into this function 2x plus 1, and it will give me an output. Okay, and now let's consider this other function, g of x equals x cubed. Okay, and if I put an input into this function, it would give me an output, another output, g of x. Now, something that you notice is if I actually wanted to get the output y, i.e. y equals 2x plus 1 all cubed, I'd actually put my x value into f of x, okay, and I'll get a result, and then I'll take that result and put it again into g of x, and I'll get my final answer for y, i.e. my final output. Now, what does this mean? We have a function that is a function of another function. Okay, so first of all, we have our first function as 2x plus 1. We get an answer, and then we take that answer, we'll put it into the next function that tells us to raise that answer to the power of 3 to give us our final answer y. So anytime you see a function like this, y equals 2x plus 1 all to the power of 3, where you pretty much have one function, okay, and then another function of that function before you get your final output, you have a function of a function. Now, if we have that y equals 2x plus 1 all to the power of 3, I'm going to call my inner function u. Okay, I'm going to call my inner function u, i.e. u equals 2x plus 1, the inner function. And what that would mean would be y equals u to the power of 3. Okay, because we have that y equals 2x plus 1 to the power of 3. If u is 2x plus 1, it will mean that y equals u to the power of 3. Now, if I have the y equals u to the power of 3, I can say that my dy du, okay, because I'm going to differentiate y with reference to u in terms of u, and basically I have that dy du is 3u squared. Now, I'm going to differentiate u with reference to x, okay, so I have respect to x, I have that u equals 2x plus 1, okay, and I'm going to find my du dx, okay, and when I differentiate u with respect to x, I have du dx as 2. Okay, so what are we going to do with these? Now look at this. The y dx, just look at these actual fractions. The y dx equals the y du multiplying the u dx. And if you actually work that, the y du multiplying the u dx, the u would cancel the u and you would be left with the y dx. What does that mean? When you're trying to find the derivative of a function, okay, you basically break down the functions, okay, so you break down the function into its two constituent functions, okay, where you have u equals 2x plus 1, okay, and then you have that y equals u cubed, okay, and then you differentiate y with reference to u, with respect to u, and what you have is the y du as 3u squared, okay, and then you differentiate u with respect to x, and you have your answer 2 in this case. And what does this tell us to do in the end? It simply tells us to find the y dx. You simply multiply your two results, okay, so you have the y du as 3u squared, and you multiply that by the u dx. In this case, we're representing multiplication with a dot, so you have 3u squared dot the u the x as 2, so 3u squared dot 2, okay, and you have your final answer. You're going to substitute u in terms of x back for 3u squared, so basically we write 3u squared as 3 multiplying 2x plus 1 all to the power of 2, okay, and then when you multiply that by 2, we have our final answer 6 multiplying 2x plus 1 all to the power of 2, and that is the y dx. That is how you find the derivative of a function of a function. Now let's do one. I think we have a few examples here. So we have example 1, and example 1 says if y equals the root of 5x squared minus 2x, find the y dx. And in this case, we actually have a function of a function, because our first function is the inner function where we have 5x squared minus 2x, and then our outer function asks us to find the square root of our results. So you have two processes here. The first one would put the input into 5x squared minus 2x, and then the second function would find the square root of the result. So you have a function of a function here, and to do this, the first thing we do, so we have y equals the root of 5x squared minus 2x. It will tell us that y equals 5x squared minus 2x all to the power of 1 over 2. Okay, and then we write that u is our inner function, 5x squared minus 2x. Okay, and then we have that y in terms of u is u to the power of 1 over 2, i.e. the root of u. Now once we have this, we can go ahead and find the y du. That's the first thing we want to do here. We have the y equals u to the power of 1 over 2. Tell us that the y du, if you differentiate y with respect to u, you'd have that the y du is 1 over 2 root u. Okay, and then the next thing we want to do is we want to work u with respect to x. So we have that u equals 5x squared minus 2x. Okay, and we'll find the u dx as 10x minus 2. So we found the y du, we found the u dx. What we need to do now is to multiply our two results, and we have that the y dx is 1 over 2 root u dot 10x minus 2. And when we multiply all of that out and substitute u equals 5x squared minus 2x back into our answer there, we have that the y dx is 5x minus 1 over root of 5x squared minus 2x. And that is, it's actually very simple. You have your first function, your second function, you differentiate the first function, differentiate the second function, and you just multiply your results. That's it, nothing much to it. Let's do another example. Okay, so example 2. Now example 2 says if y equals 4 over 3 minus x squared all to the power of 2, find the y dx. Now how do we go about doing this? So we have the y equals 4 over 3 minus x squared all to the power of 2. And then we have y equals 4 multiplying 3 minus x squared all to the power of minus 2. Okay, and then our u in this case, I think we can draw our u out, the inner function, as 3 minus x squared. Okay, and then we have that y is 4u to the power of minus 2. Okay, now step 2, we're going to differentiate y with respect to u, and we have y equals 4u to the power of minus 2. We have that the y du is minus 8u to the power of minus 3. Okay, next thing we want to do, we want to differentiate u with respect to x. We have that u equals 3 minus x squared, and we have that the u dx If you differentiate 3, you'd have 0, so we can do away with that. And if you differentiate minus x squared, you would have minus 2x. And now all we have to do is multiply our two results. So we have that the y dx is minus 8u to the power of minus 3 multiplying minus 2x. Okay, and what you have in the end is you have the y dx equals 16x divided by 3 minus x squared to the power of 3. Very simple, very straightforward. Let's move on. So example 3. And example 3 says if y equals 1 over the square root of x cubed minus 2, find the y dx. Now, first thing we want to do, we have y equals 1 over the square root of x cubed minus 2. Y equals x cubed minus 2 to the power of minus 1 over 2. We can say that our u is our inner function, x cubed minus 2, which will say that y equals u to the power of minus 1 over 2. Now, let's differentiate y with respect to u. We have that the y du is minus 1 over 2u to the power of minus 3 over 2. Okay, and now let's differentiate u with respect to x. We have that the u the x is 3x squared. Next thing we want to do, we want to multiply our two results. So we have the y dx is minus 1 over 2u to the power of minus 3 over 2 multiplied by 3x squared. And we have our answer in the end. When you multiply that out and you substitute u equals x cubed minus 2 back into your answer for u, you'd have that the y dx is minus 3x squared divided by 2 multiplying x cubed minus 2 multiplying the root of x cubed minus 2. And that would bring us to the end of this lesson. Very, very simple principle, the function of a function. Once you know you have a function of a function, you have your inner function, then you have your outer function. You differentiate your outer function y with respect to u, you differentiate the inner function u with respect to x, you multiply your answers, and there you have it, the y dx. It's actually very, very simple, very straightforward. And yeah, bye for now.